So the whole point is about give you an idea of what we're doing on the hidden side of the moon, the tool that you're using all day, what we've been doing last year, what we're planning to do in the future. So what do I mean by development infrastructure? It's all the tools that developers use to build a product, to test a product, to do all those things. That includes, of course, Gerrit and Git, which is the same thing, Jenkins, which is the CI thing, the Tinderbox, which is mostly nowadays under Jenkins, but some of them are operated by different people around. More recently, we've given some visibility to CloudBrainPerf, which is testing the performance of some part of the product. I can never pronounce that. Upsen, where is Stefan? Stefan has set up that thing, and I'm trying to get it to report properly and yell at people when it's spoken. Crash test is not yet under Jenkins, but it's going on. Bibisect, LCOV, and CP check, and we'll see that in more detail. First, the hardware. We've been growing quite a lot recently. The capacity we have to do those things to build. So TDF has acquired a few machines. Recently, we had two very big server that we run Windows on. We acquired a Mac Pro, a good one, and we'll see the number later, what the impact of that. And we have different machines that are provided. So those are TDF actual owned. There is a few of them that are rented, which are the main tree machine on which the rest of the infrastructure work, your website and the mailing list and all that. And I run, as needed, some EC2 machine to help with some platform workload as needed. We also have machine provided by volunteer, which is mostly me, but that's a different story. Mostly, if you see Dallas, that's me there. And all that together is mostly under Jenkins control to do some tasks. We have two other big machines that come in on which I'm going to make a Linux workload on it, and the intent is to get upspan, or whatever, Stefan pet project worked faster, and some others, but at least we'll have more bandwidth to do those kind of things. And we're going to keep growing over time to make sure all the platforms are balanced, and then we can get as many nice tool running on them. So Gerrit, because the first entry point is Gerrit. Right now we got a 56 Git repo, so everybody knows core.git, but there's plenty of other little Git repo. Overall, it's 30 to 30 gig of storage. We got 1,000 people registered, 150 committers roughly. Most importantly, we did 50,000 commit across all those repos last year, well, in 12 months running. And one could say only 6,000 something review patch. That, based on the number of commits, should be a little bit higher, but we're getting there. The future of Gerrit is, well, it's working, and we're going to keep it working. We usually don't have a lot of problem. And there is this inline editing that some people are fond of, and we'll review that at some point. If it's really, really something you guys want, we'll have to give in and install it. Oh, yeah, talking about Gerrit, I was reviewing those numbers. I've noticed that about 50 of you have SSH key that are RSA 1024, which is really not a good idea these days. So, fair warning, if you have one, remove voluntarily it and replace it by something, but if you don't, in a few months, they will disappear. So if that was your only key, it's going to be your problem.
Any chance of mailing with people who are guilty?
I'm just telling you, I don't want to blame everybody in public, but if you want on the mailing list to give me the list of the key and the one that are weak, I can do that too. The thing is, the script that I got didn't get quite 100% match, but I'll make the script better. So 2048 is the minimum, but yeah. Talking about that, I'm probably going to push so that we get a elliptic curve, the latest elliptic curve encryption algorithm that got in OpenSSH 4.5 or 6 or whatever. And we need to to shame David and the rest of the Gerrit community so that they have that in their SSH implementation, because they use a Java one, so that we can move to a little bit more secure keys. Jenkins. So rough idea, there is 14 jobs right now. A jobs is it's a class, and 30 job run is 30 instance of that class run every day. 14 job because, for instance, Gerrit build is one job, but you also have the tinderbox for Linux, Windows, debug, and release, that's 6 job, and there is alcohol, that's a job. So that's what a job is a task that run on a machine that do one thing. That's description. We have 17 slave box managed by Jenkins right now of different, roughly balance between Windows, Mac, and Linux. And that's performance numbers. So those numbers are in minute, the time it takes to do a Gerrit build. And the Gerrit build is a clean make build. It's not an incremental build. But some machines have CC cache, so the variation build time is important because depending on how well you hit the cache. And Windows doesn't. So Windows build time is stable nowadays. And even though the Macs here say 2 hours, 26 minutes, but really that was when I was using a Mac Mini to do Windows helper. But nowadays, the machine I have built in either 30 minutes or 40 minutes, that's typical, a successful build. Because of course, if you have a crappy thing that fails very fast, then it's very fast, right? So if you want to make it fast, you can actually make it fail, and it will fail fast. But a successful build is 30 minutes. So Mac and Linux usually nowadays run in less than 10 minutes if you have a good cache profile. Meaning if you go and change a always string header, then no, it's going to take 40 minutes. But if you do a reasonable change that doesn't have to rebuild everything, it typically can turn around in 10 minutes. Which means usually 30 minutes is what you should expect a turnaround of a Gerrit push, provided that you're within the limit of what I have. So if 5 people do that at the same time, we'll have to queue up. So if you work at night, like some of you do, or if you're lucky to live in a time zone where everybody else is asleep, like me, usually you get an answer very quickly. But it's getting faster and faster, so even though the average for Windows is 54, the real average for Windows is really 33 nowadays. And Jenkins Future. So Jenkins, it's a Java thing, like Gerrit, except it's Java done poorly. It's basically a piece of crap that it's not stable. It's nice, it come up easy, it's easy to set up, but then when you want to run it, really, it's stable, it's just horrible. It's buggy, it leaks everywhere, it's randomly break, you have to reboot it, it takes 30 minutes to get the web page back. It's terrible, I'm getting really, really pissed off by the thing. So, well, that's another meme. It's me putting a full page of whining about it, so you can read it. No point saying it. The future essentially is, I'm really, really trying very hard to get rid of it. So I'm going to look at Mozilla BuildBot that seems to have some nice feature that seems to be more close to what I want to achieve. And if it doesn't work, I'm going to write my own. That's basically my goal next year, to get rid of Jenkins. To get something that actually can work in a reasonable amount of resource, and we don't have to reboot the thing every 2 days. So with that in mind, that led me to why I eventually did that. Writing a new Jenkins meant that I had to learn how to do some kind of webby things, and so I picked up the Calgary performance testing as a good convergence. So 2 years ago, a year and a half ago, somebody started to have a VM that was collecting what we call now out-of-tree test, meaning you build a whole product and then you run it under Calgary and you collect data. And it's been running, collecting data for a while, and then it got kind of in a state of nobody was looking at it too much. It stopped working, or it worked intermittently. And recently, the idea was give it more visibility, and that's what eventually I did with this website now that produced the result of that. So what I did is I wrote basically a little bash program that managed a database that contained the result of those stats. And I modified the job that was running this VM to collect the information via this one, and all that control to Jenkins, run to Jenkins. And it put that in Postgres database, and then when it's finished running the job, it ran a script that regenerated the website, which is this website. And so the tests are classified by suites, and within the suite you have a bunch of tests, and each test got its own little result that you can go in detail. And Mogi wanted to have tests at the same time, but the entry test is the test that run as a CCP unit test. That is, so it's a unit test, but that run under Valgrind. So those are the perf check category, which is the make perf check target. So those tests allow you to have much more narrow measurement because you only measure the part that is interesting and you don't get the thing drawn by the cost of starting up and tearing down the product. So those are mostly calc tests that are more recent. And the first part, out of tree, is controlled by something I wrote, which is basically a configuration script where you define, and I have it here, I believe. Which one is it? Yeah, that's it. So in we have a Git removable test file that already contained a bunch of the test, the binary, the document that we were using. So I added a little layer that configured the suite and the test. And so in order to add a test, all you have to do is to add a little bit of configuration in those things. In in this repo. And it will get picked up because I do refresh the repo, and we'll start to start a new test, and it will automatically generate a new graph. And it will be automatically put in the right category. In other words, now the thing is set up so that developer can actually add to it without having to touch the web thing or without trying to interact at all with info, all going to show up automatically. And in the case of the entry test, they call it perf check. I got an example here of something that happened just before the conference. For instance, this guy here, see, it started, Sunday the 20th. And I didn't do anything about it. It's just that somebody added a test and you give it the right name and it executed and it got collected and populated on the web. So if you add it and it's just core.git, you just a CCP unit thing and you follow the blob, Marcus has a blob about it, how to do that. And if you do that, it will automatically show up in this website. You'll be able to track the result of those things. Now, I was there. That's the live demo. So yeah, the back of it is really simple. It's a database, and there's nice little script in Bash. I know people scare Bash, but you can do very nice things with it. Much better than Java, apparently. It's right now using JSON and just plain HTML. It's all client-side. The server does nothing. It's a solid file. In the future, we'll improve that to be able to get the graph a bit better, because right now the graph, for those, it's only a month worth of it, so it's easy. But when you get those guys here, you have like a year and a half, and there is way too much data. So the idea would be to be able to zoom in on the section of it and get only the data for the last 2 months or whatever, those kind of things. And I really need to improve the details of it, because there's too much information there, and it's really not that easy. Technically, you could hide some of it, but it's like 10 clicks to get it done. It's not practical. I need to improve this. But, you know, as I used to say, crawl before you walk, walk before you run. So that's a start at least. But there is some work to do, but it's mostly web thing work. So if anybody is Web 2.0 fan and wants to work on those kind of things, by all means, I want to delegate a lot, no problem. All right. So crash testing we have, and that's mostly, where is he? Yeah, he doesn't listen, but Quellen over there, that's his baby, mostly nowadays. Find something that runs 10,000 of things that require 1,000 of patch to be fixed, and that's Quellen, you know. Then you bring it to 0 and you keep it there. It's perfect, it's a machine. Anyway, we have this huge VM that is running every day, roughly 60, 70,000 import, export, whatever. And we're going to try to improve that a bit because I want those results to be collected in more and accessible and queryable. So I'm trying to write a backend to it, like for the perf stuff. Because today we have those results, but it's basically not that easy to export them and to show nice trend and everything. It still requires words, so I'm going to make it a little bit more integrated. But still, I mean, today it's becoming a bit too late, really, because at the beginning there was some crash. So you could see every week that things were getting better. It was like, nice graph. Yeah. Now it's boring, you fixed everything, so it's all 0, you know. Can somebody give this guy some vacation so I accumulate more crash and then, you know. Bibisect. Okay, there's a lot of work on that. Nowadays, Bibisect actually run under Jenkins for the 5.1 series. So what I call an epoch, let's go for it first. in order to find it's complicated to say which section you're bisecting, so I decided it's going to be called an epoch. And an epoch, 5.1 epoch, for instance, is starting at the branch point of the 5.0 release branch. And it's master all the way after that. And then is picking up the branch, the 5.1 branch. So if you imagine the straight line, an epoch is this section. And those point are the branch point. So 5.1 epoch, so after we branch 5.0, those are being built for Windows and Mac automatically, regularly, every 5 minutes. You go in there and you say, is there a commit to build? And if there was one, you build one, and then you go to sleep again, and it's doing that. And because those are incremental, a typical build is like 2-3 minutes. I mean, because we build those things without test, without check, without anything, because the point is to get the binary, not to make sure they build. So when you remove all that, it's a very fast incremental build, and you build roughly one commit, one build, essentially. I mean, if somebody push 10, we won't, but if you do the average size of commit, of a binary commit, it's 1 point something. I mean, it's really a lot. But in size, it's not, because those repo in the previous generation would be 5.0. You're talking about having like 8,000 commit in there, 8,000 version of the product, completely usable. You can check out, and you have 8,000 version, and all that in about 8 gig. So if you do the math, it's really not a lot per version, right? And that allow QA to debug and find regression without having to rebuild anything, and yet tell you it's between this patch and this patch. And nowadays it's 1 to 5 patch maximum. So it's once you get there, it's very easy to find where the bug came from. Right? So that's what an epoch is. As I say, we're building them. So they're on Gerrit, the one I built, which is the Mac and Windows one. They exist for the Epoch 5.0, and they are building right now regularly as we go for Pipe 1.1. Every once in a while, I go and do a GC and pull them up. So that's still a manual part. But they are available on Git or on Gerrit, and this is the name of the repo with the Mac OS 64, Windows 32, and the epoch you replace by 5.0 or 5.1.git. And these things vary from, they're big. I mean, original download, you're talking about up to 10 gig, depending on the thing. But it's a Git repo, so you download it once, and then the incremental one, you just get the difference. But if you're doing QA, it's a very useful tool to have. The message format of those things, when you get a commit on the binary section, you get a commit and it's going to say it's from me. And don't do like this guy did yesterday, send me an email telling me that I broke the build because he found that the commit in the Bibisect was from me, therefore I must have broke the build. No, it's for me because I'm doing the commit for the binary thing, but you want to look at the source shard, that's the thing that broke the code, not the binary one, okay? And the syntax, the structure of the commit messages, you have the first line is the source shard of the commit we built. And then it's repeated, always repeated there in the detail section. And then you have eventually more shard, which is all the source shard that were not in the previous build. So in sometime we do have more than one source in between two binary builds. So you have the entire list of all the shard in one thing. The consequences of that is if you do in a Bibisect repo, git glog --grab a source shard, you'll find the first binary commit that contains that source shard, which allows you to. He's looking at the front. It's not clear. If there was a source shard foo or ABC, and it turned out that you can find which binary version in the repo is the first one to contain that source commit, right? That was compiled with it. And that's a nice feature because then you can start building a lot of things to script access across multiple of those binary things. You can write tools on top of it to allow to bisect across longer range or to do whatever you want. I mean, there's a lot of things you can come up with once you have that to be able to navigate multiple repo. And that's all I had on the topic. I did mention earlier LPOV, so there is a website, and we can probably go there. Come on here. Yes, there we go. So that's run roughly every day, that do a code coverage of the different things that can be useful, and invited to write new tests to make sure there is less red in this. And that's also run every day under Gerrit. There is the crash test and what else did I say early on? Let's go back if I missed something. CCP check, and CCP check is not under Jenkins, it's running on a different VM. But there is some idea about post-processing we needed to do on this, so I'm probably going to bring it under the CI umbrella. All right, any questions?
Yeah.
Yes, go on.
I'm doing the Gerrit stuff manually. Here.
Yes.
Maybe we could bring that into that fold as well.
I could.
What was the question?
Sorry, I repeat. Coverity is actually run manually right now. There is two reasons I didn't really chase that. First, I have nothing to show for it because the only result is on a Coverity website that's behind a walled garden that you need a password to get, and so I didn't know what to show on the front end. The second one was the pushing is actually pretty hazardous. It works, sometimes it doesn't. It takes 4 hours to go through, and it's not reliable enough for me to trust doing that. And that's why I didn't. And since you do that once a week at most anyway, I figured maybe not. And you're so much on top of it that, you know, why do I care? It works already. So you're doing too good of a job for me to worry for something that runs once a week. But if you want, we can try to fix that. But it seems that it's getting worse, not better, as far as reliability of the upload and stuff like that. So I don't know.
I guess so. It's a variable time as well, a variable time slot. So it's not like you can easily send it every week. You get like 2 slots a week, and it's a bit messy.
Yeah. I'm open to try to find a solution if that becomes a problem. John, you wanted to ask something?
Yeah, about the perf check things.
Yes.
You said if anyone is interested in the Web 2.0, picking it all fancy stuff. I'm not interested in that, but maybe.
Then I don't want to talk to you.
But maybe just add down a CSV button to that, so that you can at least extract the data and load it in Cal.
What?
Just download the data, the performance data as CSV.
Yeah, well, there is an. Hold on.
Okay.
Right here.
That's your database.
It's a database, right? So, patch.com, you can get the data in any form you want. It's a Postgres database. Here's a table. It's very simple. I didn't overcomplicate it. And there is perfDB manager that you can, it's a bash script, very easy to add stuff to it. If you have a problem, ask, I'll teach you. So yeah, if somebody has an idea to do data mining about those things, there is a database. That's the whole point of it actually, is to store it in a long-term database. So the individual data is there. So there is a possibility to go and mine and find a lot of things if somebody wants. And it doesn't contain any privacy issue. It's only running tests. No person is involved in there. We didn't have to kill any cat or anything. Other questions? Yes, Norbert?
Perhaps you could stick the commit message from the original commits into your new commit message. At least cut out the likelihood of you getting named as the responsible party.
No, what I'm probably going to do is change the commit name to some generic, like I'm a bot, don't email me.com. That way, maybe. That was the first one, though. In a few years, we're doing that. The good news is some people are using it, which is actually not too bad. That was interesting. But as far as the source, I keep the shop because that big. It's just the shop because you don't want to put a partial. It's going to be too long. It's going to. I'm talking about the Git message itself. I just put SHA equal and purely the SHA to make it very easy to grab and parse and everything. Because it's rarely useful to really get the full line. And if you're concerned with that, you get the SHA. Go look at it. But being able to extract the SHA in a very standard fashion, very easily, that was more important. This, you see, only 5 minutes over, considering